At 4:23 a.m. this morning, fisherman Giuseppe Teresi felt his boat lurch sideways in calm waters off Sicily's coast. No wind, no waves, just the ocean floor itself shifting beneath him like a sleeping giant. He did not know he had just witnessed something no human had ever felt before, the underwater collapse of Mount Etna's foundation in real time. 12 kilometers below his fishing nets, billion-year-old bedrock was tearing apart along a fault line that scientists thought was dormant. But new seafloor monitoring data reveals the truth. Etna is not just Europe's most active volcano. It is 140 billion tons of rock sliding toward the Mediterranean at an accelerating pace, and gravity, not magma, is pulling the trigger. This is a time bomb. Here is the terrifying part. The same sensors that detected Giuseppe's mystery lurch have been recording systematic movement for months, 4 centimeters in 8 days. Fault slippage equivalent to a magnitude 5 earthquake, but happening silently, without a single tremor. It is as if the mountain has learned to collapse without warning. But if Etna's flank is already sliding into the sea, how much time do 1 million people living on its slopes actually have? And why are scientists now saying this collapse could trigger the deadliest tsunami in Mediterranean history? The answers lie in a groundbreaking discovery made by a team of German researchers who, for the first time, captured a volcano's submarine flank collapse in real time. What they found challenges everything we thought we knew about how mountains fall apart. In a remote operations centre 1,200 miles away, in Kiel, the scientists watched in stunned silence as their array of seafloor sensors painted an impossible picture. A massive Manhattan-sized slab of volcanic rock was sliding toward the Ionian Sea at a rate of over half a centimetre per day. Even more alarming was where this movement was happening, not at the peak where magma pushes the volcano to its limits, but along unseen faults deep underwater, where the mountain's own weight is tearing it apart. As geophysicist Felix Norman said, "This is a complete game changer. We have always assumed that volcanoes fail because of magma pressure from within. But what we are seeing here is a volcano destroying itself from the bottom up." The breakthrough came in 2016, when a German research team led by Dr. Marilia Urlaub installed an array of 5 underwater transponders off Etna's coast. For 15 months, these precision devices pinged the seafloor every 90 minutes, creating an unprecedented real-time map of the mountain's submarine movement. In May 2017, this network captured something extraordinary, a 4 centimetre slip along a deep fault over just 8 days. It was the first time a volcanic flank collapse had been detected as it happened. The data it revealed was alarming. Etna's southeastern slope is sliding as a single block towards the Ionian Sea, with movement increasing the farther you get from the magma chambers. That is the exact opposite of how a volcano should behave. Even more disturbing, the fault extends over 30 kilometers offshore, far larger than any scientist had predicted. Perhaps most unsettling of all, this slippage is happening entirely without earthquakes. The displacement data suggests a silent event with a moment magnitude equivalent to a 4.3 to 5.3 earthquake, enough to cause severe damage onshore. Yet it is all happening underwater without so much as a tremor. Over the last 24 months, Etna's flank movement has accelerated dramatically. Coastal GPS stations now record a relentless millimetre by millimetre creep toward the sea. Satellite radar shows the entire southeastern slope deforming coherently seaward. In 2025 alone, Etna erupted 3 times, each event correlating with a sharp increase in flank displacement. The June blast launched an ash plume 21,000 feet high, while submarine sensors registered a simultaneous acceleration below. Then, for the first time in 3 decades, the feared northeast crater roared back to life in December, another sign of the intense geological stresses now warping the mountain. Leading volcanologists are sounding the alarm. Dr. John Murray of the Open University calls the prospect of catastrophic flank failure absolutely devastating. Dr. Urlaub has issued a chilling warning that we cannot exclude flank movement evolving into catastrophic collapse. The Italian National Institute of Geophysics minces no words, declaring Etna's seaward slippage poses a much greater hazard than previously thought. But it is not just the velocity of Etna's collapse that has scientists worried, it is how far the mountain has moved already. According to Dr. Urlaub's calculations, the southeastern flank has slid a staggering 4 meters since her team's monitoring began, an astounding distance for a landmass weighing tens of billions of tons. Even more concerning is evidence that Etna's ancient flank failures may have been preceded by similar slow-motion slippage. Core samples drilled from the volcano's submarine flanks reveal layers of rubble and debris up to 300 meters thick. Mixed within this volcanic breccia are ancient soils, river deposits, and even tree trunks, the remnants of entire landscapes carried to the bottom of the sea. The implications are chilling. As Dr. Murray explains, these deep-sea deposits suggest that Etna's prehistoric collapses involved not just the flank, but massive portions of the onshore volcano as well. We could be looking at a scale of failure we've never seen in modern times. With so much land already in motion and millennia of geologic evidence pointing to past mega-collapses, the question facing eastern Sicily is no longer if Etna's flank will fail, but when. Dr. Urlaub sums it up bluntly: it's not a matter of if, but when. And right now, all signs point to sooner rather than later. To grasp the urgency of this threat, we need to rewind 500,000 years to Etna's fiery birth. This stratovolcano, the largest in Europe, formed above a subduction zone where the African plate dives beneath the Eurasian plate. The result of that 500,000-year collision is a towering stack of lava and ash layers reaching 2 miles into the sky. Ancient legends say buried giants still shift beneath Etna's flanks. But the real story may be even more dramatic. Geologists mapping the Sicilian seafloor have uncovered evidence of at least one massive prehistoric flank collapse 8,000 years ago. The slide carved the Valle del Bove, a 4-mile-wide horseshoe-shaped scar on Etna's eastern slope. Landslide deposits from this single event extend 25 kilometers underwater, with a total volume equivalent to 500 Empire State Buildings. Tsunami traces from the collapse have been identified on coastlines across the eastern Mediterranean. Since then, Etna has settled into an ominous rhythm. Frequent summit eruptions alternate with rarer but more destructive flank eruptions. Records show at least 60 of these lateral blasts since 1600 AD alone. The infamous 1669 eruption sent lava streaming into Catania and permanently altered the Sicilian coastline. More recently, significant flank events in 1928, 1971, 1981 and 1991 involved magma rising through cracks on the volcano's sides, a sign of the mountain's growing structural instability. But Etna's current slow-motion collapse is uncharted territory. Never before have scientists seen a volcano's flank sliding seaward so relentlessly without any link to magmatic activity. This is gravity alone pulling the mountain down, and no one knows how to predict when the creep may suddenly accelerate into catastrophe. The stakes of such a collapse are nearly incomprehensible. If the entire sliding flank, covering 250 square kilometers, were to break off at once, it would be the single largest landslide in recorded history. The resulting tsunami would be equally unprecedented, says geophysicist Dr. Raphael Paris. Using advanced computer modelling, Dr. Paris and his team created a virtual simulation of Etna's flank failing all at once. The initial wave generated by this collapse reaches an astonishing 250 meters tall as it barrels toward the Ionian shoreline at speeds topping 400 kilometers per hour. Within 10 minutes, a wall of water 50 meters high would crash into Catania, flattening the city instantly. Even 30 minutes after the collapse, 20-meter waves would be battering the coasts of Greece and Libya. This flattening surge would arrive with almost no warning for many communities. Dr. Paris grows somber as he considers the human toll of such a catastrophe. In their simulation, they estimate casualties could easily top 1 million in the first 2 hours alone. By the end of the first day, the numbers are difficult to even conceptualize. It would be a humanitarian disaster, unlike any in modern European history. Yet what makes Etna's threat so insidious is that even a much smaller flank failure could still unleash untold devastation. A collapse involving just 10 to 20% of the sliding rock mass, a volume on par with many prehistoric events, would still yield 40-meter tsunamis slamming into eastern Sicily. Even this more moderate scenario would rank among the top 5 natural disasters in European history, jeopardizing up to 250,000 lives and causing hundreds of billions in economic damage. The sheer range of possible outcomes is one of the most daunting challenges facing volcanologists and emergency planners. How do you prepare for a catastrophe that could unfold over hours, days, or decades? How do you evacuate 1 million people from an impact zone larger than some European nations? The grim calculus of Etna's flank collapse requires confronting possibilities that once seemed unthinkable. 1 million people live in the shadow of Etna's unsteady slopes, many of them in towns and villages sitting directly above the sliding flank fault. Densely populated communities like Zaffarana, Via Grande and Giare all lie within the highest risk collapse zone. Sicily's second largest city, Catania, sits just 30 kilometers south of the most geologically unstable terrain. The Catania metropolitan area is home to over 300,000 people, with hundreds of schools, hospitals, and critical infrastructure facilities all within reach of the volcano. The single evacuation route for much of this population is Highway 120, a narrow road that winds directly through Etna's active eastern flank. Even a minor eruption can render this lifeline impassable. If the mountain's seaward slippage suddenly accelerates, escaping the danger zone may become impossible. When Etna finally collapses, the scale of destruction would be almost unimaginable. In an instant, billions of tons of rock would plunge into the Ionian Sea, displacing a monstrous volume of water. The resulting tsunami would reach 30 meters in height, before slamming into Sicily's eastern shores just 5 minutes later. From there, the waves would race outward in an ever-expanding radius of death. Malta and southern Italy would be hit in 15 minutes. Within an hour, every coastline in the eastern Mediterranean would be engulfed, from Greece to Libya to Egypt. Current models predict over 20 million people across 6 nations would face severe flooding, with thousands of kilometers of densely developed shoreline at risk. Economic losses would soar into the trillions as ports, refineries, and transportation networks are smashed by the waves. And all this destruction would unfold with almost no warning. The Mediterranean currently has no tsunami alert system, and the submarine sensors that might detect a flank collapse are not connected to any hazard mitigation network. The result would be a cascading infrastructure failure of epic proportions. Sicily's electrical grid, heavily dependent on now destroyed coastal power plants, would crash within minutes. Water treatment facilities would be contaminated just as broken pipelines lose pressure. Roads would become death traps as drivers flee the coast, while hospitals and emergency services are paralysed by power outages and fuel shortages. Across the Mediterranean, ports would shut down, severing the maritime trade routes that are the region's economic lifeblood. Overnight, southern Europe and North Africa would face a refugee crisis not seen since World War II as millions of survivors seek safety inland. This is the nightmare now lurking beneath the Mediterranean, one that could be unleashed in the geological blink of an eye. And it is a threat that scientists are only beginning to understand. The difficulties of predicting such a catastrophe are immense. Unlike earthquakes or eruptions, Flank collapses do not telegraph their final failure with increasing tremors or accelerating fault movement. In Etna's case, the transition from gradual creep to sudden collapse could occur with scarcely a seismic whisper. This troubling lack of warning signs has left researchers scouring Etna's geologic history for clues. Dr. Julia Crummy of the British Geological Survey has meticulously dated past flank collapse deposits using paleomagnetic signatures and ash layer chronologies. Her findings paint a sobering picture. While smaller submarine landslides occur relatively frequently around Etna, at least once every 1,000 years, the mountain's catastrophic mega-collapses follow a significantly longer rhythm. The last comparable event, which created the Valle del Bove, happened 7,600 years ago. The one before that has been dated to 15,000 years ago. Dr. Crummy says we are confronting the possibility that Etna is now primed for another Valle del Bove scale collapse. In geologic terms, the mountain is overdue for a full flank failure. Even more concerning, the time between Etna's last two mega-collapses was 2,000 years shorter than the interval separating its last catastrophic failure and today. Dr. Crummy's research also underscores a haunting parallel. The period preceding Etna's collapse, 7,600 years ago, was marked by a sequence of increasingly violent eruptions, a pattern that bears striking resemblance to the volcano's activity over the last 150 years. For Dr. Crummy, the implications are clear. We have to consider the possibility that Etna's recent eruptions are not just isolated events, but warning signs of a major structural failure already in progress. As you read this, a battery of GPS stations, seismometers, and satellite sensors are all aimed at Etna, searching for the slightest twitch that might signal an impending disaster. German and Italian research teams are rushing to deploy even more monitoring equipment, not just on Sicily, but near other slumbering giants like Stromboli and Vesuvius. Yet even with these Herculean efforts, science still cannot predict when slow slippage might accelerate into sudden collapse. Dr. Urlaub is blunt. We just have to keep an eye on Etna's flank and how it is moving. Her team is now scouring the data for hidden patterns that could serve as early warning signs. They are tracking how eruptions and earthquakes affect flank movement, watching for any spike in slippage rates. Satellites scan the mountain for new fractures and thermal anomalies that could indicate structural failure. Volcanic gas emissions are monitored for the slightest uptick that might correlate with unseen fault activity. The chilling implication is that Etna may represent an entirely new class of risk, flank collapse with minimal magmatic warning. If so, coastal volcanoes worldwide may be silently sagging seaward right now, undetected. The same factors destabilizing Etna, gravity, structural weakening, prehistoric slip faults, threaten iconic peaks from Kilauea to Fuji to Vesuvius. It is a staggering thought. Entire mountains, millions or even billions of years in the making, all sliding into the sea while we watch unknowing from above, collapsing not with the roar of eruption, but in awful silence as their foundations simply dissolve. Yet that is precisely the scenario that Etna's data now forces us to confront. And it demands action from scientists, civil authorities, and ordinary citizens alike. Because one thing is clear, we are all, in a sense, living on the slopes of Etna now. As Dr. Murray reminds us, catastrophic collapse occurs worldwide about 4 times per century. Dr. Urlaub warns that the hazard might be underestimated at other coastal volcanoes. The challenge and the urgent necessity is to close the gaps in our understanding before the next collapse strikes. Because if Etna's slow-motion disaster has taught us anything, it's that the solid ground beneath our feet may be far more fragile than we ever dared imagine. But there is still reason for hope. Around the world, scientists are mobilizing on an unprecedented scale to meet this emerging threat. Coastal communities are beginning to integrate flank collapse scenarios into their tsunami preparedness plans, and public awareness of these hazards is growing every day. Here in Sicily, a new sense of urgency now infuses the work of civil authorities and emergency responders. Detailed evacuation procedures for eastern Sicily are being updated and drilled in cities and villages alike. Underwater seismic networks are being expanded with the ultimate goal of enabling real-time tsunami alerts for the entire Mediterranean basin. Yet even as we race to prepare for the unthinkable, we must also confront an unsettling truth. No amount of planning or mitigation can eliminate the risk that Etna and other coastal volcanoes now pose. We are living, quite literally, in the shadow of mountains that could come crashing down at any moment. Perhaps that is Etna's most profound lesson and its most urgent warning. In an age of rapidly accelerating climate impacts and ever more complex infrastructure interdependencies, we are all now inherently vulnerable to catastrophes that once seemed unthinkable. Whether it's rising seas, superstorms, or collapsing mountains, the message is clear. The time to prepare for previously unimaginable disasters is now. On a planet in flux, complacency is a luxury we can no longer afford. Subscribe now for updates as Earth Attacks continues tracking this existential threat and the scientists racing to get ahead of it. In the comments below, let us know, do you believe world governments are prepared for a volcanic catastrophe on this scale?